Today, I want to demonstrate a security problem that is surprisingly unsolved in most enterprises. Modern traffic is encrypted end to end, and because of this, deep inspection of payloads is now effectively blocked by default. Attempts to close this exact gap. Internet where HTTPS is everywhere, all traffic is encrypted. So, when we try to analyze the packet in firewalls, we are restricted to using metadata only. Because of this, almost all modern security monitoring is unable to determine the exact contents of the packet, which is the source of all problems. If something malicious is happening, the payload is what's going to contain the information. The security leaks or anything that is happening will happen in the payload. The credentials and any type of new exploit can be prevented if we are able to analyze the payload using intelligent techniques. So, our approach is somewhat innovative. It is to stop thinking of AI as a classifier and start using it as a semantic interpreter of payloads. We can legally decrypt HTTPS by acting as a man in the middle through a proxy server and a technique known as deep packet inspection, where we use our own certificate to establish a connection, a TCP handshake, with the client, and another one using our own certificate with the server. We can install this certificate onto the client's operating system, and this way we can act as a reliable middleman which intercepts all traffic, decrypts it, analyzes it, and then forwards it to the server if it is found to be safe. The way we do this precisely is by the use of two different models. So the first one is an LLM that simply analyzes the content of the payload to determine security risk. So an LLM is a natural fit for this task since it's able to understand what is the content and what's written there and understand the semantic meaning behind it. So you can find out if certain types of tokens are there. The LLM itself is paired with a set of static rules which determine when the LLM should be executed. So on all packets, we don't actually need to run the LLM, obviously, and it will slow down the latency a lot. So we do this intelligently by using a set of static rules which determine if the packet should be inspected. So something like a TCP handshake or acknowledgement packet does not need to be analyzed by an LLM, but something that contains potentially security data needs to be analyzed. Either we let the packet through and analyze it parallel with the LLM, or we, if to determine the security risk to be high, we first analyze it and then determine if it needs to be blocked or rejected. Since we have access to the payload, we can do much more than just use an LLM, and that's what we have done. Once an LLM finds a security issue, it can then run our second model, which is designed to generate a static rule to encounter similar issues in the future. So it can use things like regular expression and generate like a Python function that can be used for the payload. So this is our main idea, is we have not just an LLM we also have a adaptive firewall which can upgrade itself over time. Our overall architecture can be coupled with existing architecture such as traditional firewalls as well as modern firewalls based on machine learning approaches on the metadata, and it provides it a stronger backbone for separate kind of attacks that cannot be detected from metadata alone. So in this way, we came up with a new approach to solve the problem in security and network security by tackling the problem at the source itself. So this is an effective philosophy, and if the threat lives in the payload, the defense must understand the payload